This is example 4 from the Rational Functions Part 2 lab. We have the following function. It's already been factored out for us. We want to find some attributes of this function, such as horizontal asymptotes, oblique asymptotes, vertical asymptotes, and if it has any holes. So looking at this function right now, as it's factored, we have it as x minus 7 times x plus 2, and the denominator is x plus 2. So we know that x plus 2 and x plus 2 will cancel. And because of that, we know that x plus 2 is essentially leads to a hole. In other words, at x is negative 2, there's a hole. So if there is a hole at x equals negative 2, we actually need to write the hole as a point. And so to find the y value at negative 2, we can't just plug it into here because we'll get something undefined. So we need to actually create this function as a new function after the hole is already canceled. So canceling this x plus 2 in the top and the bottom, we get the new f of x as just whatever's left, which is x minus 7. So now if we plug in x equals negative 2, we have negative 2 minus 7, which is negative 9. So at x equals negative 2, we have a y value of negative 9. So our hole is at negative 2 and negative 9. So moving on, we're going to look for vertical asymptotes. Because this x plus 2 and this x plus 2 cancel, we actually don't have any vertical asymptotes. So there's not any vertical asymptotes. So for horizontal or oblique asymptotes, we need to look at the degrees of the numerator and the denominator. So the degree of the numerator is the leading exponent of the variable. Here it's x. So the leading exponent, the greatest exponent, is this 2. So the degree of the numerator is 2. And the degree of the denominator is 1, this invisible one right here. So we have a case where the degree of the numerator is greater than the degree of the denominator, which means, and it's by exactly 1, which means that we have an oblique asymptote. So writing that rule as follows: the degree of the numerator is greater than the degree of the denominator by exactly 1. We have an oblique asymptote. So the way we find that asymptote is we can go through with long division. However, by dividing this numerator by the denominator. However, if we actually go through with that, because the denominator shares a factor with this numerator here, going through with this division will only leave x minus 7. So there's actually no need to go through all of long division because we already know what we will be left with. And what we will be left with is this x minus 7. So there's an oblique asymptote at y equals x minus 7. And so filling out our little chart here, we have no horizontal asymptote, but we have an oblique asymptote at y equals x minus 7.